So we have the same panelists what we had in Dr. Stewart's session. So I will just start with the presentation, and then we will follow with the Q&A session. I hope you won't get disappointed, just in case if Q&A session we are not able to answer each and everything within an hour or so. You can just shoot out an email to us, ask your queries so that we can answer them later on also. Uh, okay, I hope my audio is clear to you all. Okay, good. So this is what is there in continuation with Dr. Stewart's session on Asteroid Day. So I will just give one intro video which was prepared by my NGO team member, Cavalia, about the Asteroid Day. Just in case if audio is not
to create an awareness in the people. So by creating awareness, we can save this earth, families, and the future generations on this earth from these catalytic reactions. And this is started from 2014. Following this, NASA and UNO also declared it as an International Asteroid Day. Every year it is celebrated on June 30th. And why should we select this as an asteroid day? So on June 30th, as per historical records, the first asteroid to give an gigantic react is this Tunguska. On June 30th in 1908, a large asteroid has hit an Asteroid in the forest area in Russia, which is in the size of a large country today. That is in the size of Washington DC.
The main purpose of Asteroid Day is that Asteroid Day June 30th is selected. Why? Because there was a Siberian in 1908. There was a Siberian asteroid collision that happened on Earth in Siberia, in the suburbs of Siberia, Russia, basically. So what exactly happened is in the Tungska River area, 40 miles away from all the population and everything. So that blast happened basically when an asteroid just hit our Earth. So all these stats I will give a bit later on. So what happened is that at that time there a lot of shattering noise, and a lot of people were impacted. Many had fallen here and there, and many kind of destruction was there in a way. And then all the trees and everything in that surrounding area, the core area, which is still impacted after 1908 till 2020, no trees have grown, the area is still as it is. So asteroid had made a change in that particular land. So then it was there, and then actually after a lot of years research work was going on, and then everyone realized that why we should study asteroids. And even NASA and other space centers also agreed along with the United Nations to make it as a asteroid day, International Asteroid Day. So every year this International Asteroid Day on June 30th is celebrated to mark this particular event, sad event I would say. So that is the reason why we have this International Asteroid Day. So now why it is important to study asteroids and everything we will cover up. So as Bill Nye say, if the Earth gets hit by an asteroid, it's game over. It's control all done for civilization. So in the prehistoric times when dinosaurs were there, and obviously they could not protect themselves, right? We are humans, we are smart enough, we need time, I know, but still what happens is that if we ignore this problem, then it's a big going to be a big mess for us. We won't be able to protect ourselves, and we will just simply die. uh, Pandemic is there, I know, other things are there, but still we will come out of all these situations. But how will we protect ourselves from asteroid is how we scientists and everyone is trying to work on it. So that's how that is the importance of asteroid day. This is a repeated slide. So asteroid day is a dynamic awareness and educational program to inspire the world about asteroids, their role, formation, and how it can help us explore further. So exploration is going on if we have to extract minerals and all, and simultaneously research work is going on. What is the composition? How we can actually defy the orbital mechanics and deflect them whenever anything is coming. Just one second. I hope you guys are able to see my video. So just in case if this is our Earth, right? So if any meteorite or anything impacts the Earth anywhere, right? Meteorite is just a small chunk, but whereas asteroid is a huge chunk of size of the city or suburbs, and that too it not just impacts the city. If suppose anywhere in the sea or beach, seaside or ocean side, it impacts, then also a lot of interaction happens. Uh, it interacts with our soil, the earth crust, and everything, and it distorts everything. So basically, it impacts to miles and miles, and it will have an impact on various other states, countries, everywhere. Okay, so it is not something okay. Asteroid just came in, and on ocean it is making an impact. We are safe. No, it is not the case. It will have an impact on everything, everywhere. Uh, just one second. I think someone is having audio problem. Or what? Okay. Anyways, yeah. So going forward, basically, what is stardust? That is a critical aspect. What I wanted to explain before going on how asteroids were formed or how meteorites were formed, and even planets. So this is just to give a crux of what is stardust or dust. So basically, Spitzer Space Telescope took this particular image of Cat's Paw Nebula in 2018. So all these composition, green, yellowish, orangish, red, says a lot about how our solar system must have formed and how the dust came into picture. So dust is basically when the sun was a disk, basically revolving and shooting out all the gases and everything. So a lot of electrostatic pressure, electrostatic forces were acting. There was no gravity at that point in time because there was single object. This was just like a supernova in this second picture, just exploded. The smog, what you can see right now. Okay. So now what exactly happened is that when the fusion of simpler hydrocarbons and smog, PH, polycyclic aromatic hydrocarbons, which are complex forms or chains of hydrocarbons basically, they under pressure and electrostatic force, they just try to combine what Dr. Stewart also told the earlier in the previous session. So at that time, they started forming this particular kind of small particles. I hope you can see my screen. Then these gradually small particles further interacted and formed small stony objects, what you can see over here. So that's how our planetary or proto-planet planetary solar system came into picture. It's a long process. There are a lot of videos on YouTube also how this was analyzed and come to a conclusion. And then these are just this is a pic of microscopic pic of a meteoroid sample. So these all these small chunk of particles or further granule particles. Uh, okay, just one second. Live stream is not working, I guess. Mm, just give me a minute. Issues there. There it is. So I will just continue. YouTube live stream will start in a while. So that's how the dust, stardust, or dust came into picture. The way we explain dust over here, sorry, I think that was the YouTube video. So basically, stardust, or what we call on Earth, the dust particles, they are very thick, and we can just carry a handful of dust basically. But the actual dust which formed the solar system and everything, which was of very minuscule, they were very minuscule smog type dust. What it comes out of chimney or the fire, wood fire or everything, even minuscule, very fine than that dust also. Sorry. So this is how the solar system formed. So proto-sun was there. There was a Big Bang, as you all know. A lot of theories are there, different theories. So out of this supernova and all, so gases in the form of a lot of electrostatic pressure and electrostatic forces in picture. So it started forming and revolving and rotating basically to form dust particles. So it all of a sudden bursted in a way, and a lot of pressure was there, a lot of electrostatic uh, uh, interactions were there, which formed the dust. So dust in further interactions formed small chunks or handful, and then it kept on combining planetesimals. And then the gravity concept of gravity, barycenter, and everything started coming into picture. So everything started revolving around this protosun, which was just forming. And then our terrestrial and gaseous and everything started forming. So the last picture, what you see, the last line. So this is our sun, Mercury, Venus, Earth, Mars, the asteroid belt, then Jupiter, Saturn, Uranus, Neptune, and then again the Pluto or dwarf planet disk, basically. Vishnu, we will get back to you. I have covered that in my slide actually. So this is how the what I was explaining, just trying to explain that prototype sun and everything, rocks and everything was just roaming about here and there, and then due to interactions and collisions, a lot of collision was happening. Even now, somewhere outside the solar system, something will be happening because there are many things going on which are unknown to us basically. So then Thea and all that concept came into picture. Thea collided with our planet Earth, which was again forming, which was volcanic at that time. And that collision Earth-Moon system was formed, and similarly all other planetary systems were formed. Whatever moons are there, or whatever twin moving dwarf planets are there. Okay, so what is the difference between comets, asteroids, and meteoroids? So again, there was a video. I'm not very sure whether you will be able to listen to it.
Namaste everyone, I am Adarsh Sajjan. I want to talk about asteroids on the occasion of Asteroid Day. These are the asteroid models I made. You can see that they are all in different shapes and sizes. Asteroids are large space rocks which drift around in the inner solar system. Most asteroids lie in the asteroid belt between the orbits of Mars and Jupiter. The asteroids in the asteroid belt are locked together due to their own gravity. The best example for an asteroid is Vesta. It is the largest asteroid in the asteroid belt. The asteroid belt also divides the inner solar system and the outer solar system. Now let's discuss about the importance of researching on asteroids. We can protect our Earth by researching on asteroids. 66 million years ago, an asteroid named Thea hit Earth. It had the potential to cause the catastrophic mass extinction. It wiped out 97% of life on Earth, and only 3% life on Earth survived. So if another asteroid like that hits Earth, then Earth would be an unlivable planet. So if we want to protect our Earth, we need to research carefully about asteroids and on their moves, because asteroids occur suddenly and without any warning. And asteroids also contain valuable metals like iron, copper, nickel, cobalt, and they are also rich in diamonds. Asteroids also contain rocket fuel like liquid oxygen and hydrogen, and coal is also present on asteroids. These resources are very valuable on Earth because they are very limited on Earth. Scientists are planning to send robot miners to the asteroids to mine and research further about them. Now let's discuss about the importance of studying asteroids. No two asteroids are the same. Many asteroids vary in shapes and sizes. The largest asteroids can be the size of 20% mass of the moon, and the smallest can be the size of houses. And some asteroids have moons, one even has rings, but some asteroids can be very mysterious like Oumuamua. Oumuamua is a rogue asteroid which entered the solar system in 2014, and it was discovered in 2017 by the Hawaiian Space Telescope. It completed an orbit around Mars and it headed for the Sun. When it reached halfway to the Sun, it suddenly changed direction and it headed out of the solar system. No one knows why it did that, but I think it was pushed away from the Sun due to the solar storms happening on the Sun's surface. But it is still not proved that why it changed so mysteriously.
So basically, what happens is that comets are the in a way, pre or solar system formation. When everything was starting, the comets were also formed. So comets are of different type and different orbital mechanics is there. So some orbits are so long that it takes 200 years or less than 200 years or even more than 200 years to cover the orbital part. So what comet we just saw today or tomorrow might not be seen for decades to come, or even our generations to see. Like Halley comet is there and others are there. So there are different categorization of comets and meteorites and asteroids. So comet is a small body made of ice and dust that leaves a tail of gas and ice as it travels near the sun. So basically, this is the first images of a comet pic with a tail, and the other one is the that of a nucleus, basically. So it's again a rock, icy rock, I would say, in that way. So what happens is that once, suppose if I am just taking a dummy example, this is my sun, and comet just comes over here and goes again. So when it is interacting with the sun, comet does not have, comet does not have light of its own. So everything is due to sun, just like moon. The moon does not have the light of its own, or even the earth, right? So comet does not have any inbuilt light material source. So when it comes and interacts the ice and everything, all those molecular parts and the material basically shines in the opposite direction of the sun. So sometimes what happens is the tail uh, covers the space. Tail is such a spread across miles and miles, basically in between 1 AU or even more than 1 AU. So which means that Earth and Sun, whatever distance is there, even tail can exceed that one also. So that is how long the comet can be. So now coming to a meteoroid, it's a small rocky part or a part of a parental asteroid or planet, whatever collision has happened or will be happening or might be happening now also. So it's a small rocky body in space, which is size of from microns or small chunks to 10 meters. So meteoroid is what forms a meteor and then a fireball, and then comes and lands on our Earth as a meteoroid finally. Just one second. So next is asteroid. As you have seen, asteroid is a large rocky body in space. So basically, the difference between meteoroid and asteroid is just that size is there. Plus, meteoroid is not in itself something, but just a part of the parent, right? So if suppose if today I have this Earth, and if I break it into chunks, so that chunk is known as a meteoroid, nothing else. Okay, so meteoroid and asteroid difference, I hope it is clear. Then meteor is the light part when it enters our atmosphere, the lighting due to a lot of atmospheric pressure and heat which is generated. So that light which emits, that is known as a meteor. So basically what happens is, again I'm taking an example. So this is our Earth, this is our atmosphere. So suppose if a meteoroid passes through our atmosphere, but it does not actually land successfully on the Earth, or maybe it can just bypass our atmosphere and go somewhere else in space if it is still alive, I would say. Or if it is coming over here, till the time it is in the atmosphere, it is known as a meteor. Okay, so meteor is the light emitted from the meteoroid as it enters the atmosphere. It may burn up completely. It might be able to enter our atmosphere successfully and land on the Earth. Basically, that is known as a meteoroid. So meteoroid is the final version of what we get and what we collect actually. So fireball is a meteor brighter than the planet Venus. That's just a comparison of definition, just like IU has a definition of planets, dwarf planet, and all. So fireball is much bigger. Even it can lit up the night sky as if you are reading a book. You don't even need a light. So it will look like a daytime. You must have seen a lot of videos, or even in news channels, it keeps on coming that in this particular city or country, something has been lit up all of a sudden, basically. Okay. Just, and then basically meteor shower is slightly misconception. Meteor shower is an event that occurs during a particular time or month, what we call on calendar month, what we call on the Earth. which is the number of meteors that radiate, and when it is passing through, our Earth is passing through, revolving basically, revolving around the sun. So in the month of October, when winter is about to start or something like that, so it is in a particular direction in space. So at that time, whatever leftover meteors are there, part of or debris of comets, basically, they are there. Small chunks keep on trying to enter our atmosphere in that particular constellation or something. So I just want to clarify one thing. Constellations are, again, if you have attended our basics of astronomy, constellations are nothing but just an imaginary lines, right? So constellation doesn't mean that all stars are forming some pattern. They are just our imagination. So the sun is very far out. Similarly, Betelgeuse is there. Other stars are there which are forming that particular constellation. So they are at a million and million of light away, far away, right? It's just that in 2D we are able to see as a constellation. So when I say a meteor in the month of October or November or December or April month, then what is happening is we are just taking as a constellation as a reference. So we call a particular terminology over there, radiance basically. So the constellation from where the meteor shower starts is the name of the meteor shower typically. So like I will give some example. Perseus is there, Orinoid is there, Orion basically, and other stuff is there, something like that. Okay. So this is the second image is an example of an asteroid, and then this is the oldest one, meteoroid. I will come to that part. What we have found on the Earth basically. So see, asteroids are very difficult, almost zero visibility when you see at the night sky. Even if you go to Antarctica or Himalayas or any suburbs, Greenland, Ireland or Iceland, wherever, whatever country you go. So asteroids have to be discovered. Of the first asteroid series was also discovered via telescope. When space shuttles and everything concepts were uh, coming up later on, or first thing to discover is via telescope only always. But however, sorry, in this case, comets are basically very bright. They have that tail also at times, so it is almost visible. And in olden days, what happened is that in olden days we did not have that much of light pollution. There was no concept of electricity at all, right? We are talking about 1680s also, and even prehistoric times also. Obviously, not all of them would have understood, okay, what this is going to be called in future, right? So the comet was very much visible, maybe with Milky Way and different stars also, not like city area. So all these writings are there from the church, German church. So this is how the event started, and they were not able to understand what this comet is. So they called everything star. Star was burning. It was a bad luck basically for them. So star was burning, something bad is going to happen. So that's how they have explained everything. So in the name of Jesus, so please keep your blessing and all that stuff. So this is how comet descriptions were given over there. So now comets basically consist of multiple, I would say, structure. Not like asteroid or a meteoroid, just a rock. It has multiple things. So whenever it is coming to a near to the sun, it has a long tail. Otherwise, it does not have any tail when it goes far off or outside the solar system or something like that. And then there is a coma, the light or the area covering the nucleus, the main core nucleus, right? So so basically, it is purely made up of dust, rock, and ice, dirt ice, I would say. And most of the comets are far away, and orbital period is also long. So there might be many comets which we are not even explored or aware of, and there are hardly a handful of comets which have been observed and confirmed. So around 3,553 or maybe approximately have been confirmed so far. So now, as the comet approaches the sun, it shows a coma and the tail. So that's what is shown in the picture, right? It started as showing as diffusion and tail and whatever light is there. due to heat basically. So it builds it on gravitational atmosphere. So atmosphere is there. In case of asteroid and meteorites, no such as such atmosphere is formed in that sense. So it has its own gravitational atmosphere wherein the ice and the dust are just forming that particular tail. So just like Earth Moon system or debris around the Jupiter Mars, so it is also forming a kind of a tail in the form of debris. So it is believed to be originated from the Kuiper belt or Cooper belt and the Oort cloud. So there are different. I think I have covered. Okay, yeah. There are different types of comets, Jupiter family, which just comes out of Jupiter and then revolves around the sun, which has an orbit of around less than 20 years. Again, it depends. It has long elliptical orbit also. Then Halley categorization is there, which is 20 to 200 years. So when last Halley comet was seen, it was 1986, right? So again, the orbital time taken to orbit around the sun is very high. Then we have the comets which are coming via Oort cloud also, which takes more than 200 years. So I don't know who is going to see those comets and when. Okay. Uh, So I will have to be a little bit quick because it's in our session. There would be many things which we will cover up later on. So yeah, so this nucleus is basically a core of a comet, the rock which I showed you over there, the very first picture. It consists of rock, water, ice, frozen gases, and dust. So it is not exactly the ice what you see. It is a combination of dust, water, molecules in a way, and everything whatever it carries along with it. So there is a possibility that comet has actually made its mark on the earth and it has given the life form also earlier. So so they are the one which are less reflective objects found in the solar system. So the size of nucleus is typically less than 60 kilometer. So asteroid can be very less and very huge also. So coma is the coma part which you are seeing over here is in general made out of H2O molecules and dust. So its size across may vary, may be larger than the sun, thousand or million kilometers. It again depends, and its size basically decreases when it crosses the orbit of Mars because it is carrying, as I told earlier, a gravitational atmosphere. So whatever debris are attracted towards it, so everything comes into picture when a long tail is formed. Then when again it is going far away from the sun, whatever orbit it is taking, then again it loses all its atmospheric properties at that time. So it may or may not happen. We are yet to study all these mechanics. So yeah, just moving on. So asteroids, sometimes known as minor planets, because they are moving around, revolving around the sun. So they are rocky, airless remnants left over from the early formation of our solar system, approximately 4.6 or 4.7 billion years ago. But there is a misconception that asteroid are kind of a planet was there or protoplanet was there, which with the interaction of Mars and Jupiter, it blasted off due to gravity, and then the remains are there. That is not the case. If you combine all the masses of these asteroids, smaller chunks, they will not be able to, what our definition of planet is there, it will not even able to form the planet. Maybe just a small chunk or a minor planet also, but still it won't form a planet. So that is a misconception. So asteroids and planet follow the same path around the sun. Cycle is obviously different, like what is the revolution time of Mercury, Venus, Earth. So similarly, asteroid also have what Dr. Stewart also earlier mentioned. This was supposed to be an animation. Unfortunately, it is not working. So what I'm trying to say over here is that suppose if two asteroids are just going in a straight line or a particular defined path, if any heavier object or planet with higher gravity and other forces are there, then what will happen is some of the asteroids will behave trying to get attracted towards the that particular planet. Or what will happen is due to that push and pull of gravity between two planets, right? What will happen is that particular asteroid will start to wobble and it might even break into chunks. That's how the asteroid and everything keeps on integrating also at that time. Sorry. Uh, so the next one is asteroid size range is typically 100-meter to so small size of a house to 1,000-kilometer size of a city also, or even bigger. So they are composed of carbon or iron. So earlier also we have discussed carbon caseous is there, which does not have, or least there are further subcategories. I won't go into detail. I will have to take a separate session, chemical composition and all. So carbon caseous are there, iron and nickel and other materials are there. Iron and nickel plays a vital role. I will come to that also. So asteroid belt, basically what you are seeing over here, right, is a group of rocks that appear to have never joined to make a planet. So basically, they could have easily combined into Jupiter rather than being a gaseous or towards the Mars if that tug of war was not there in the picture. So that could have made Mars more bigger in size, or it could have formed some small, more better debris, or even combined with series. That's how it works basically. So meteoroids are interplanetary rocky, I mean parental part of asteroid, chunks of asteroid, which are smaller than 100 meters towards the grain size. So even a grain size can enter our atmosphere if it survives, which obviously it will not. Then it is known as a meteoroid. So if it makes it to a ground, it's a meteoroid. So it's basically a survival of a fittest, to be very honest. So most of the meteor shower are the result of Earth passing through the orbit, what I've told earlier, through the orbit of a comet which has left debris along its path. As you are aware, space is totally empty. There is no atmosphere. Nothing is there, right? So that is the reason why that meteor chunk or whatever debris are there left over by asteroids, comets, everything remains there, or at least they are just moving around. There is no atmospheric pressure. If I throw a ball, it is going in a particular direction. So if I throw the ball in our atmosphere, it will come down at some point or the other, right? Whereas if I throw a ball in a space, it will keep on moving at a particular direction at a particular velocity speed. So these are the impact creators. I think this one is Arizona. So meteors are typically rocky, mainly iron and nickel, as I've told. So all this I'm skipping as of now. So meteors are old enough, 4.5 billion years, based on the carbon dating what we do. So the carbon dating what we do for trees and other materials works very well for asteroids or even meteoroids or even meteoroid samples or other things. So this is the meteor shower. You can just Google it out, meteor showers. Orionite is there in the month of October. This is approximate date. Leonide is there, and Geminide is there. Gemini basically. So quadrant radiance is there, what we call technically. So there are different type of meteor showers you may or may not see. Even a guy like me who is living in light pollution city area, Delhi, right? So I am able to see around 3 to 4 an hour of the major Perseus is there and Orionite is there, all these meteor showers. So obviously from clear sky, you will be able to see lots and lots, maybe 20 to 30 or 10 to 15 meteors going on. So, and one more thing I just wanted to clarify. In Hindi, we call it as a Toota Tara, right? Or a shooting star. It is not a star. So basically, the star formation is totally different. Stars are not moving, and they will not come very near to our Earth like that, except for the sun. Sorry. So what happens is that's a conception that okay, star was there. It is moving from one direction to another. That is a meteor shower, or what we call it as a meteorite falling, or it could be anything. So that is a rocky thing which is entering our atmosphere and just lighting up or burning basically, right? So that's how we there is a misconception of Toota Tara or a shooting star. So these are some of the samples which have been shown. So they are black, rocky, carbonaceous, very less metallic part, or maybe they are rich in iron and nickel content. So these are the pieces of asteroids which are known as meteoroids, which have survived our atmosphere. So thanks to our atmosphere, thanks to our Earth system, which have been protecting us for millions and millions of years, including dinosaurs and all. Obviously, if a bigger asteroid comes or any such rock or anything hits, obviously there is a limit to everything. So atmosphere won't be able to withstand all these things. So on other planets, like even the moon does not have, or very minuscule thin atmosphere is there. That is the reason a lot of micro meteoroids keep on hitting this other planets or the moon also. So how are they different from the Earth rocks? Uh, this I have discussed with Dr. Stewart earlier, but still I'm just explaining pictorially. So, as he mentioned that the Earth rocks have gone through a lot of dynamic process. So basically, what happens is earlier stages, igneous rocks were there. Everything was burning out, right? Volcanism and everything. When the proto-Earth was there, then it cooled down all of a sudden. Then this age, Ice Age, Stone Age, and all that stuff came into picture. So Earth has gone through a lot of atmospheric changes. So weathering of rocks has happened. Chemical interactions, alterations with wind, water, and other external factors have been there. So within soil, if suppose a meteorite just enters, it is a fresh fall, right? So then what happens is all the meteorite collectors or government authorities or space agencies, they try to collect that meteorite as soon as possible. Why? Because obviously they have to understand the composition and everything. It is fresh. Secondly, the more you delay it, suppose if a meteorite falls in a on a Siberia part, which is a remote site, which was earlier a remote site, I would say. So what happens is we won't be able to explore that area. So with weathering of rocks, rivers, and everything, rains, water, so it will mix up with the materials or the what do you call minerals of the soil. So it will be very, very difficult if I go after 10 years or 20 years or 50 years and find out a meteorite like rock. If I even take it in a lab, lot of impurities, earth impurities will be there, and lot of weathering will be there. So physical, even the physical actually persona will change. That is the reason why I mean, scientists always try to collect the meteorites as much as possible earlier. So this is the oldest Canadian bedrock. Australia has some part in Africa. Dating obviously is different. So this is more than 4 billion years, and maybe the oldest one, which is known as the early Earth's crust. So this has been there. So if I compare this rock with all other rocks, they will be younger. Just like on Moon, we have old rocks or the new rocks comparatively. So this is how the comparison is done. So this is very vital for scientists to study further. So this is a Hayden rock sample which are exposed on the Earth's surface. These are the geologic shields of Canada, Australia, and Africa. So this sample of Genesis from the side of the Earth's oldest rock, the Casta River in Canada again, is a sample which has been dated to 4.3 billion year old. This is not a gold, as you can see. They are phyllates and other minerals also in this. So this is Murchison meteorite, which is carbon dated to be around 7 billion year old, which is older than our solar system and even the Earth. So this meteorite was a God gift, I would say. In Jan 2020, astronomers reported that the oldest material found on the Earth to date is the silicon carbide particles from this particular meteorite, which have been confirmed and determined to be 7 billion year old. So this is a recent study or analysis which has been done, and which is about 2.5 billion year older than the our Earth and the solar system. So you can go to this link and explore more about old rocks. There are, I think, 7 to 8 such rocks. So asteroid belt. So this is our solar system. Asteroid belt is basically typically between Mars and Jupiter. So basically, Sun, Jupiter, and Saturn played a vital role in having this asteroid belt. So they are rock with sizes greater than 100 meters across, which I have already told. And then beyond the Neptune area, It is there. So most of the asteroids remain in the asteroid belt between Mars and Jupiter, but few have orbits that cross Earth's path. This was again explained by Dr. Stewart in the previous session, if you have attended. This is I'm just comparing with Hollywood movie. Obviously, many people are now aware how asteroid belt looks like, but still many compare that we won't be able to pass any spaceship like Voyager is there, or New Horizon is there, or Juno mission is there. Many think that they are fake. What they were just told that okay, this Cassini reached Saturn and it basically was destroyed by Saturn's atmosphere. Many think that asteroid belt is something a barrier for us. We cannot even cross it. So this is how Star Wars movies and Empire, Millennium Falcon, and everything has been shown. It looks really exciting. It looks very dangerous, but it is not the case. So all these things, blasting off and sonar and radar radiations and blasting off everything, is not technically what happens actually. And then this is the attack of the clone basically. So they are detecting an asteroid over here. Something is coming. So now sonic boom is there and everything is destroyed within few seconds. Then some blasts are there and all those things, and they land on an asteroid. So maybe in future we will be able to commonly land on the asteroid, but that doesn't mean that this is how the asteroid belt looks like. I will share just one thing. I was programming something, but unfortunately I could not get much time. Just give me a minute. Yeah, so I'll just reshare my screen just to show you. It's not yet complete actually. So I hope you are able to see this part, right? I was just programming something in the morning also. So basically, Earth, Mercury, terrestrial planets are there. I have to obviously correct my calculations to show the mass nearer to the Earth. But this is the asteroid belt, suppose. So asteroids are not in the same exact linear orbit. So one asteroid will be like this elliptical, the other one will be like this or like this. And distance also and the speed of rotation and everything will vary. Not all the asteroids will have the same speed, just like in planets also, right? Retrograde motion and everything is there. Moons are moving in this direction, some are moving at a very slow speed, or some planets are just taking 200 years or 100 years maybe. So something like that. Asteroid also has a certain speed and the orbit also. So orbit is not the same round circle what we see in the 2D like this. It is not always the same. Sorry.
Find these asteroids and keep on tracking them. Asteroid hunt campaigns are being conducted all over the world as a group of people cannot check thousands images per day. I participated in the asteroid hunt campaign conducted by Spaceport India Foundation with the collaboration of International Astronomical Search Collaboration (IASC). In 2019, at September-October month event, I made two provisional discoveries of main belt asteroids. These asteroids are not discovered by analyzing the images from the backyard telescope, but we are discovering these asteroids by analyzing the images taken by Panster telescope, which is in Haleakala, USA. These asteroids are temporarily named as 2019 SQ25 and 2019 SH42. 2019 SQ25 orbit the Sun once 3.4 years and 2019 SH42 orbit the Sun once in 5.2 years. My discoveries will be made as a part of Minor Planets Catalog maintained by International Astronomical Union. Minor Planet Center is responsible for identification, designation and orbit computation of all minor planets, comets and outer irregular natural satellites of major planets. Minor Planet Center will keep the records of these two asteroids for years to come and will monitor further to keep a track of them. I thank Spaceport India's founder Samir Sachdeva sir for his technical guidance and support to participate in this event. So I thank you all for watching this video and I hope you all learned something new.
Yeah. So as per theory, Jupiter migrated towards the Sun and then returned to its current position because of complex gravitational and other forces interaction with the Saturn. So Jupiter played, and Saturn and Mars, to a certain extent, I would say, played a vital role in forming this asteroid belt. So it's kind of forming a asteroid, basically coming near to the Sun, then going back, gaseous form and everything. So asteroid also had a lot of material included. So coloration of the asteroid also, just like meteoroids and asteroids also have multiple colors. So again, I will have to take another session for this one. So this is how an asteroid belt, or maybe this is just a pictorial representation. Even wider space is huge, and the asteroid belt is also huge in comparison to the distance. So any spacecraft which is traveling and going out of this asteroid belt, they just have to deflect a bit with the help of thrusters, what they have actually, just like what you have seen in the videos or live feeds also at times. So they detect, okay, something, blockage or barrier is coming in between, and they just slightly move here and there, not like uh, Empire Strikes Back or Falcon Millennium and all that stuff. So that does not happens. Aditya, I will come to that part. I think we have discussed earlier also on how to purchase meteorites. That is not allowed in India actually. Even if someone is selling you, that is illegal and fooling you around, unless it has a genuine certificate and lab test reports. So asteroid belt is not what is shown in the movie, what I was discussing. So all these technical details are there. You will be able to find on internet also. So there is an outward distance, so the Trojan area also is there around the Jupiter, which due to certain balance act, they are stuck in that Jupiter or near to Jupiter or behind the Jupiter, I would say, uh, uh, orbit, basically. As Dr. Stewart mentioned about the Kirkwood gaps, so basically Jupiter is revolving around the Sun, and asteroids are also three times resonance is there. So if an asteroid makes three orbits at the time Jupiter orbits once, right? So resonance and everything, mathematics basically, I would say, Jupiter gravity will kick out the asteroid, and then it will form that gap. So not everywhere, just like on the Earth, gravity is not the same everywhere on the Earth. So similarly, on asteroid also a lot of impact is there. Push and pull is there. Somewhere gravity will be weak. So basically, asteroids are not going in a straightforward direction. They are wobbling. So it's like this and moving like this. So they may or may not change the path little bit. They may deviate from their actual path depending on the gravity and how far it is from the host object or the planet, basically. So that's what exactly happens. Why we have near Earth object also. Sometimes these asteroids they basically collide to each other, and debris come towards inner planet or go outside. We don't know. So if anything is going towards Saturn and everything, then obviously its atmosphere will take care of it. So asteroid path is more or less the same if I am observing or taking a picture of an asteroid via telescope, right? So what will happen is that different pictures in 24 hours or certain set of hours, it will give me image like asteroids are moving in a straight direction compared to the my background. So if I have a background which is static, right, in a cinema hall or something, I have a static cinema hall show is going on. If a person is coming towards me, I'm sitting upstairs and he is bringing popcorn or Pepsi. So he is coming via stairs in a straight line. I'm just giving a random example. So basically, what is happening is the asteroid is moving whereas stars are static. Stars are more or less the static ones which are there. Obviously, Earth's revolution and everything happens a lot. So by that time, asteroid must have gone somewhere else in the space. So this is how this asteroid trail basically looks like. In a linear form, it simply goes away. So the asteroids are the relics we have already discussed to the effects of Jupiter and other mass-sized objects. Jupiter's gravity helped shape the asteroid belt. Even today, its gravity is playing a lot of role, and it's depleting the certain orbits of the within the asteroid belt. So a lot of impact is there. So Lagrange point, maybe I will cover in some other. Lot of mathematics is there again. Why, how this angle and everything, all these things are calculated. So basically, these are the Trojan asteroids which are trapped in stable points, basically, where the gravity is very stable in a way between the two host objects or with effect from the Sun and the Jupiter, basically. So whenever it is revolving around the Sun, just like Jupiter revolving around the Sun, so these are typically in between, not in between, but around the Jupiter only at times. So this is why Trojan basically hidden ones. So we don't know, we are hardly able to find them or see them via telescope or otherwise. Okay. So basically, Yarkovsky drift also Dr. Schwartz spoke earlier. So that is one of the reasons. Basically, asteroid spin is there. It is moving around the sun and in between gravity of Mars or Jupiter. So basically, at times gravity is weak also. So it keeps on spinning, just like this. Not like our Earth, which is rotating in a tilted axis, basically. So it's wobbly motion, basically. So what happens is whenever it is coming towards the sun or the gravity, so heat is going on, a lot of friction is there. So what at that time what happens is asteroid will simply go off if the gravity is weak. It is able to escape its orbit, so it will just shoot out, basically, or it will just come inside towards the sun or towards the terrestrial planets. That's how NEO also plays a very vital role. So smaller particles, smaller asteroids basically interact with each other's orbit, and that is known as van der Waals forces. Again, this will be covered in different sessions. So how we classify asteroid meteorites? Just give me 1 second. It's already 6:23. Sorry. Uh, okay. So main belt asteroid, which is there between Mars and the Jupiter, then Trojans are there, which are near to the Jupiter, hidden ones. Then near Earth objects are there. So different sizes are there. You might be having those news channels saying that uh, today doomsday is there and this and that is there, but nothing has happened so far. So many news channels we have heard in so many years, right? It can happen. That's why we are studying asteroids. So that is the reason why it is really very important. So this is the asteroid compositions. Similar composition is there with meteorites. Classification is different based on the composition. C-type chondrite is there, which is very minimal uh, iron or metallic part. Silicates, mostly silica, and they are very dark in appearance. So there are different colors also, and these are the one of the most these are the common ones, and these are the most ancient ones. Why? Because when not even planets were there or not forming, these debris were rotating and revolving around the sun, right? So they did not had much of interaction or impurities from other planets to asteroids. So if Earth is rotating, right, and revolving, so if asteroid is nearby, but it does not interact with the Earth's soil or atmosphere, that asteroid remains intact. That asteroid contains a very vital chemicals or materials or dust particles which tell us how old our solar system is or what is the composition, what was the composition. So it is not an impurity since it has not interacted. Just like the moon and the earth, they have interacted and they kind of collided and head-on collision was there. So a lot of properties are similar of earth and the moon. So this is an old map. A lot of updates keep on coming of the impact sites, known asteroid impact sites. These are the ones. So this is very important. Apart from Siberian impact, Chicks Club is when the KT line and the dinosaur age basically ended. That's what our analysis says. So a lot of drilling was done. This is a diamond drill, and it was drilled just like petroleum we drill, right? So this is how the Chicks Club basically looked like, and geologists and scientists were very amazed to see this part, how this such a geological formation can happen actually. So at that time, what happened is that they explored further. They invested money with approval from government and all. They found the crux and everything. And this is the KT line fossils and everything. So that's how they